Good morning, children. Today we are going to deal with the new chapter of ninth grade, which you already learned in your lower grades. That is about the number system. Under the number system, which you already learned in your lower sections, like in your primary, pre-primary, middle school, and now we came to the high school, where you learned in the primary level, you learned the number line. About the number line, you learned actually about the number line, where we have a zero exactly in the middle, and we have the positive values. Onto the right side, you have your all positive numbers, and onto the left, you have all negative numbers. For example, 0, 1, 2, 3, 4, 5, so on. And to the left, you have the negative numbers like -1, -2, -3, -4, so on. So this is your number line, which you used to draw previously, which you learned in your previous grades. This is your number line, where we have all set of numbers. For example, if I started from 0, okay, I started collecting all the numbers from 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, so on. All these positive values, we call them as natural numbers. Generally, it is denoted by, you know that it is denoted by what? The letter N. N stands for natural numbers. So it is denoted by N, which are all positive values. Then we have, to this set of natural numbers, if I included 0 to it, if I added a 0 to this value, 0, 1, 2, 3, 4, 5, so on, we call it as what? Yes, those are whole numbers, which are denoted by W. W for whole numbers. So those are all positive numbers which start from 1, 2, 3, 4, 5 are natural numbers, and we added 0 to it, to the set of natural numbers. We call that set as whole numbers. And to these whole numbers, if I add some negative numbers, then we get -3, -2, -1, 0, 1, 2, 3. So you have your natural numbers, you have 0, and you had added all the negative numbers. We call this set as integers. We call them as integers, which you learned in your 6th grade, maybe 6th or 7th grade. So these integers generally are denoted by the letter, most probably I, or I can use the word Z, or you can use the letter Z. Z stands for Zahilin, which is a Greek word, which means to count. Which means to count. In German, we call it as Zahilin, Z for Zahilin, which is need to count. That is the letter that they gave it for the word, the integers, the set of integers, which contain 0, the positive, and the negative numbers. Together, we call it as integers. So these are the sets which you already learned, which already you know it about, which already you learned in your lower grades: natural numbers, whole numbers, and the integers. If you observe here, all these natural numbers are there in the whole numbers, and all the whole numbers are there in the integers. Then comes the new one, that is, which already you learned, that is your rational numbers. What are these rational numbers? What are these rational numbers? Maybe you learned this, basically these numbers which are in the form of P by Q or A by B. I can take any letters. For example, if I take in P and Q, or in P and Q are some integers, they belongs to a set of integers. They are integers. These P and Q are integers. It can be 0, positive, and the negative, where if I written in the form of P by Q, where Q value is not equal to 0, your denominator should not be 0, because if the denominator, or if the Q value, if it is 0, then it is undefined. We cannot define. So that is the condition, is what Q is not equal to 0. So all the numbers which are written in the form of P by Q, I'll call them as what? Rational numbers. And generally the word rational, R stands for ratio. That's the reason P by Q. Or generally it is denoted by the set of rational numbers are denoted by, the set of rational numbers are denoted by Q. Do you know why Q? The word is derived from R for ratio, rational, but the set of these rational numbers, which are in the form of P by Q, are denoted by Q, and the Q stands for a quotient. Why? Because we will divide P by Q. We are dividing. So what is the answer we'll get after simplifying? We call it as quotient. What is the value we'll get it? So that's the reason it is denoted by the set, the letter Q. So all the rational numbers are denoted by Q for quotient. But the example, if I take in the rational numbers, if I take in the example of rational numbers, if I take in P and Q are any two integers, for example, I take in -3 and -5 as my P and Q values, then I can write as -3 by -5. It is a rational number. If I take in 5 is a rational number. I can write as 5 by 1. If I take in -2020 by 2019, it is a rational number. If I take in only a positive value, 2030, then it is also a positive number. It's a positive number and it is a rational number. Why? Because I can write as P by Q, 2030 by 1. So these all are the examples I can take, a lot of examples I can take. For example, if I take in 0, is it a rational number? Yes? Yes. Why? Because I can write the 0 as 0 by 1. So we call it as a rational number, which is the form of P by Q. So it is a rational number, where Q is not equal to 0. So I can say that I can give a diagrammatic form of all these things, what we learned: natural numbers, whole numbers, and integers, and rational numbers. If you observe, all natural numbers are whole numbers, all whole numbers are integers, all integers are rational, along with that some other, the mix of these negative and positive numbers, I can make some set of other set of rational numbers. So if I take in the total number system, yeah, we learned what actually is a number line. Then we learned what are natural numbers, what are whole numbers, what are integers, what are rational numbers. We have another set of numbers which are called irrational numbers, which we are going to deal with, which are not rational numbers, which are not in the form of P by Q. We call them as irrational numbers, which we are going to deal in the coming chapter. So in this chapter, we are going to learn the coming topics. What are these irrational numbers? Generally, these irrational numbers are denoted by Q dash or S, which are not rational. We call them as, for time being, you can understand as, which are not rational are called irrational numbers. Okay, then if I take in the set, if I take in natural numbers set, if I take in this as a natural numbers, which are 1, 2, 3, the positive values as one set of box, and these all natural numbers are whole numbers. Why? Because what are whole numbers? To these natural numbers, I added 0 to it. I added 1 0. So the whole set will become what? The natural numbers, and the 0, the include the whole, we call it as the whole numbers. Means along with these natural numbers, we have zeros included in that, then the whole total set we call it as whole numbers. Then these whole numbers again are merged into what? Along with these positive numbers, which are natural numbers, and 0 is included to it, we call it as whole numbers. And to these set of whole numbers, if I added some positive value, if I added some negative values like -1, -2, -3, so on, we call this total set of box, the total set as integers, generally denoted by Z. We already learned that. Then these natural numbers, the whole numbers, and these negative numbers together, we call it as what? Integers, which are denoted by Z. And along with these integers, if these integers are again merged into what? The one more box, we call it as rational numbers. So what are these rational numbers which are in the form of P by Q? where q not equal to 0 means all these integers, all these whole numbers, all these natural numbers comes under these rational numbers. Along with that, some other numbers you can include in that, like 5 by 4, 7 by 9, minus 2001 by 58, so on. All these are rational numbers generally denoted by q. Got it or not? Then, so I can say that all natural numbers are whole numbers. Very good. All these whole numbers are integers, and all these integers are what? Rational numbers. Got it or not? So, but vice versa is false. Well, because all rational numbers I cannot call it as integers, all integers I cannot call it as whole numbers, all whole numbers I cannot call it as natural numbers. Got it? Is it clear? So all natural numbers are whole numbers, all whole numbers are integers, all integers are rational numbers. These are some set of numbers. Along with that, we already discussed about irrational numbers. That is completely a different set. We will write it separately. Okay, that is a different set. We call it as what? Irrational numbers, which are denoted by q dash or s, generally denoted by q dash or s. And this total set of numbers which are rational and irrational together we call it as this total set, we can call it as real numbers. These are the main numbers in the whole number system. What we learned from your levels, actually from grade 4 or 5, you started learning natural, whole numbers, then integers, then rational numbers, then you are going to learn irrational at this stage, and together we call them as real numbers, which will have a continuity in your 10th grade. So these are as number system, are numbers, what we have, what you have in your topic. And these, from this I can say that all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers, and irrational is another set, and the rational and irrational together we call them as real numbers. Now we are going to learn about rational numbers, and we'll see some exercise problems. Yeah, we actually learned regarding the rational numbers, what are natural, what are whole numbers, what are integers, what are rational numbers, what are irrational numbers. Together we call them as real numbers. Now we are going to learn, now we are going to solve few problems of your exercise 1.1. If you see the first one is 0 a rational number? Can you write it in the form of p by q, where p and q are integers and q not equal to 0? The main question is 0 a rational number? What could be the answer? What could be the answer? Yes, 0 is an integer, but 0 is also a rational number, but because all integers are rational numbers, and I can write 0. Yes, answer is yes. Why? Because I can write 0 as 0 by 1. I can write in the form of p by q, where q is not equal to 0. So I can say that 0 is a rational number. Why it is a rational number? I can write 0 as 0 by 1. 0 by 1 will be how much? It will be a 0. So it in the form of p by q. I can say that, and the other way is that all integers are rational numbers. I can say that 0 is a rational number. So therefore, answer is yes. That is your first problem. And 2 and 3 we'll see the coming classes. And the fourth one is about state whether the following statements are true or false, and to give reasons for your answers. We need to give the answers, reasons for your answers, what are you getting. If you see the first one, every natural number is a whole number. Is every natural number whole number? Yes, all natural numbers are whole numbers. Is it clear? But because 0 extra is included in the set of natural numbers, if I add 0 to it, then it becomes a whole numbers. So every natural number is a whole number. So is it true or false? So it is a true. Why it is true? Why it is true? Why it is true? All natural numbers are whole numbers. They belongs to whole numbers. All natural numbers are in the set of whole numbers. That is the first one, first one. Then every integer is a whole number. The reverse, the converse is asking, or the vice versa. Is every integer is a whole number? Is it true or false? Every integer is a whole number. Every integer should be a whole number. Yes, it is false. Why it is false? We have few set of numbers in integers which are whole numbers. What are those numbers? Yes, that is, those are negative numbers. For example, -3, -5, -2, -1. All these negative numbers are integers, but they are not whole numbers. So that's the reason every integer is not a whole number. But the reverse, the vice versa is true. Every whole number is an integer. Is that clear? Good. Now we'll go with the third one. What we have is every rational number is a whole number. Is every rational number is a whole number? What are whole numbers? You know it, 0 and set of natural numbers. What are rational numbers? Which are in the form of p by q. We call it as rational numbers. So all rational numbers are whole numbers. Yes, maybe few of you think that it is true, but actually it is false. Why it is false? Because we have some set of numbers which are not whole numbers, but they are rational numbers. So can anyone tell me what are those numbers which are rational numbers, which are not whole numbers, which are in the form of p by q? For example, if I take 5 by 7, it is a rational number but not a whole number. If I take -8 by 9, it is a rational number but not a whole number. So on, I can take some rational numbers which are not whole numbers. So every rational number is not a whole number, but the converse or the reverse, the vice versa will be true. Every whole number is a rational number. Is that clear? So we had solved some set of two problems. We are going to discuss what are the next class. We are going to discuss what are those rational numbers between any two rational numbers by using the mean method and by the same denominator, which we are going to discuss in the next class. And I'll give you one homework problem, the example problem, which we'll send to you. Thank you. Have a nice day.